Welcome to the Effective Instruction in Mathematics Across Tiers, Tier 2 module. This is the second of 3 modules and should take 27 minutes to view. In the Effective Instruction in Mathematics Across Tiers, Tier 2 module, there will be 3 main objectives. First, we will discuss how MTSS applies to mathematics at the Tier 2 level and consider what effective instruction and intervention looks like, as well as ways to enhance and support academic engagement. Then, how to match intervention to need, and finally we will discuss how to identify intervention programs. The overall viewing time for this module is 27 minutes. We have already discussed in the last module the components of effective core instruction for all students. During this module, we will continue that conversation by discussing the components of Tier 2. The instructional focus continues to be core instruction. Instructional expectations are still the Florida standards. Intervention will occur in small groups based on skill deficits, and progress is monitored more frequently. For example, on a bi-weekly basis. Let's begin with the purpose and characteristics of Tier 2. The purpose of Tier 2 instruction and intervention support is first and foremost to improve students' performance of core expectations. Tier 2 is considered successful when 70% of our students receiving the Tier 2 supports meet or exceed the core expectations. As we move the problem-solving process around these groups of students, the focus is on instruction. We must ensure that we are implementing evidence-based instruction and interventions that are matched to the specific needs of the students. The document seen here, MTSS Implementation Components, Ensuring Common Language and Understanding, can be located on the Florida Problem Solving and Response to Intervention website, along with other resources to support your implementation. The direct link to the PDF has been provided for you at the bottom of the slide and can also be found in the resource section of this module. Tier 2 is more intense than core instruction, meaning that there is increased time. The instruction has a narrower focus, focusing on the skill deficits, and the group size is smaller. Intervention may be provided by a variety of professionals, such as not only the general education teacher, but also possibly an intervention teacher or math coach. Intervention also may occur either in the general education classroom or an alternate setting. An important factor to remember is that time allocated for the intervention is in addition to the time that the students are receiving in core instruction. When developing an effective multi-tiered system for mathematics for students that are struggling, this tool provides guidance with recommendations for instructional practice. The 2 recommendations that show the strongest level of evidence are recommendations 3 and 4. Both of these will be discussed throughout the module. This report is also available in the resource section of the module. Data are used to determine specific areas of need. Here is an example of sources that a Florida district has utilized to make decisions regarding instruction and intervention for math. A comprehensive understanding of barriers to mastery of learning objectives allows for development of effective instruction and interventions. For example, if student understanding of key mathematical vocabulary is a barrier, then explicit pre-teaching of vocabulary should be included within the instructional design. When determining common needs, we must consider multiple sources of data that can be utilized to determine common student needs, such as screeners and diagnostics. The same progress monitoring data that tells us a student is not responding to core instruction may also tell us that secondary intervention is not sufficient to help the student reach his or her academic goal. After the intervention has been adapted, we continue progress monitoring to determine if the changes have been sufficient or if we need to make additional changes. Some progress monitoring tools are brief assessments, repeated measures that capture snapshots of student learning. They are reliable, valid, and evidence-based. There are 2 approaches to progress monitoring: mastery measures and general outcome measures. The main difference is the ability to look at the data across time. Master measures are a snapshot to let us know if students are learning the specific skill currently being taught. An example of this is multi-digit addition with regrouping, taught and assessed in isolation. All problems on the probe would assess only one skill at a time. General outcome measures, or GOMs, are program independent and can be used with any instructional approach. They can serve as both screening and progress monitoring measures. They reflect a year-long curriculum and have problem types randomly placed. The following are questions for consideration when designing intervention for Tier 2. What instruction or intervention will be provided during that time? How much time is needed each day to accelerate skill development? Who will provide the instruction or intervention, and where will the instruction occur? When determining what the instruction will look like for Tier 2, there are things to consider, such as ensuring that we are focusing on the skills that are posing the barrier to acceleration of learning. We do that by analyzing data and clarifying the picture of student need. We get the biggest bang for our buck when we can group students with like needs and focus our resources. This way, we are able to determine what evidence-based interventions will address the students' needs and begin to close the learning gaps, getting our students back on track towards the core expectations. Some components of Tier 2 instruction for math are a drill repetition practice procedure. This is critical to build mathematical fluency. Segmenting or chunking information into parts so that students can then synthesize the information later. Providing students prompts and cues which control the difficulty of the task. Having the opportunity to utilize technology, and modeling mathematical problem solving. Effective instruction in math at the Tier 2 level should incorporate foundational or prior knowledge and bridging the learning that has already occurred. Ensuring the opportunity to practice with visual representations builds conceptual knowledge. We will discuss more about this in upcoming slides. Increasing opportunity for practice is vital. Building the students' capacity to do the mathematics can be accomplished by providing them opportunities for practice of newly learned skills with direct support and immediate corrective feedback. Motivators to help students regulate their attention and behavior and to work hard. Assessing students' interests, hobbies, and extracurricular activities, relate content objectives to student experiences, support instruction with humor, personal experience, incidental information, and anecdotes that represent human characteristics of the content. Use divergent questioning and brainstorming activities to stimulate creative thinking and risk-taking, and vary instructional patterns and activities. When designing Tier 2 instruction and intervention, these are 6 key principles that have been identified by the RTI network. We will cover each of these in the following slides. Instructional explicitness. Students who struggle in math benefit more from explicit instruction than from discover-oriented methods. Teachers must directly share the information that the students need to learn. Instructional explicitness is comprised of overtly teaching all steps needed to complete a task, use of teacher modeling followed by guided practice, pacing instruction to match students' learning needs, and scaffolding instruction to support and move toward independent practice. Modeling in mathematics is vital to developing a conceptual understanding. Here are just a few examples of concepts that are easily modeled using concrete and visual representations. The Internet has several free resources for providing students practice with virtual manipulatives. This website is the National Library of Virtual Manipulatives, provided by Utah State University. The National Library of Virtual Manipulatives is a library of uniquely interactive, web-based virtual manipulatives or concept tutorials, mostly in the form of Java applets, for mathematics instruction with a K-12 emphasis. Illuminations is a resource for teaching mathematics provided by the National Council for Teachers of Mathematics. Illuminations increases access to quality standards-based resources for teaching and learning mathematics, including interactive tools for students and instructional support for teachers. Instructional design that eases the learning challenge. The goal is to anticipate and eliminate misunderstandings by means of precise explanations and with the use of carefully sequenced and integrated instruction. We need to close the gaps as quickly as possible. We can begin by teaching foundational skills that students can apply across mathematics. Teaching must be systematic, meaning that we break activities into small, sequential steps that students can progress manageably through from simple to complex. And we must ensure that students possess the appropriate pre-skills and prior knowledge and understanding for the new skill being taught. Something additional to consider is that over 50% of students with math disabilities also have reading disabilities. As during the Tier 1 discussion of the module, one of the biggest bangs for our buck that we can provide for students in mathematics is the CRA approach to learning through multiple representations. Learning and understanding mathematics at every level requires student engagement. Mathematics is not a spectator sport. Too much of current instruction fails to actively involve students. One way to address the problem is through the use of manipulatives, physical objects that help students visualize relationships and applications. We can now use computers to create virtual learning environments to address the same goals. There are several examples provided here, but there are many, many more options to choose from. The assessment of students' knowledge of procedures should provide evidence that they can recognize when a procedure is appropriate, give reasons for the steps in a procedure, reliably and efficiently execute procedures, verify the results of procedures empirically using models or analytically, recognize correct and incorrect procedures, generate new procedures and extend or modify familiar ones, and appreciate the nature and role of procedures in mathematics. These are provided by NCTM's Principles and Standards for School Mathematics. An emphasis on drill and practice includes practice in sorting problems into problem types, the mixing of problem types within the daily lesson, and daily review. An emphasis on drill and practice includes practice in sorting problems into problem types, the mixing of problem types within the daily lesson, and daily review. In order to reduce error rate in responding, we must provide instruction with ample practice so that accurate responses become automatic. A math example is, in an effort to build math fluency, intervention includes a procedure requiring students to repeat a problem type multiple times, thereby increasing the probability of a correct response, several times after making an error to reinforce learning, developing rapid recall or automaticity of the skill such as multiplication facts. To do this, we can provide the integration of content and strategies across settings. For example, utilize the pre-teach, review, reteach strategy specifically to pre-teach concepts or missing core foundational skills, such as fractions prior to algebra, and preview skills to be taught in core instruction, such as mathematics vocabulary. Provide authentic opportunities to practice skills in a variety of settings and generalize concepts and strategies. In mathematics, educators can provide investigations or projects that involve real-world application of skills that can incorporate multiple content areas. For example, a simple project would be to determine the height of the flagpole in front of the school. A more involved investigation that could include multiple content areas would be a car accident that involves the math that a police officer or crime scene technician would need to use to determine the distance that the car took to stop when stepping on the brakes and skidding the tires. Use explicit instruction with guided practice and corrective feedback to show students where and when to apply skills. We can do this by modeling, providing guided practice, and providing opportunities for independent practice. Any math skill can be taught using a gradual release model. Effective Tier 2 materials for mathematics will emphasize matching the task difficulty to the capability of the students in the group, providing high numbers of opportunities to practice the skill and receive performance first under tightly controlled and stable conditions, and later as the skill improves under variable conditions, such as with different materials, different problem presentations. Cumulative review. Providing continual reliance on the foundational skills taught in the introductory unit and the use of mixed problem types within conceptual instruction, sorting practice, and paper and pencil review, or through the use of technology. Motivators. At-risk students often display attention, motivation, and self-regulation difficulties. Keeping students interested in mathematics and understanding how math relates to their everyday lives is key. The math teacher is the first responder. The math teacher knows the core expectations of the Florida standards and is the primary contact with the student. The MTSS plan for math should include strategies for the alignment of intervention to core instruction, as well as instructional adjustments or accommodations that need to occur. There are resources which identify high-quality intervention programs. Many resources are available to identify high-quality intervention and match to student need. Success will only occur when intervention is matched to student need. The problem-solving process continues to be vital in the determinations for instruction and intervention supports provided for the identified group of students. Problem identification and problem analysis will be crucial to the development of a hypothesis prior to implementing an intervention plan. The same question should be considered by the team. However, in Tier 2, the supports will be provided to a group of students with like deficits, not the whole group. When we are determining how we are going to maximize our efforts to match intervention to student need, we must first understand the student need. That is accomplished by identifying and analyzing the problem by utilizing the problem-solving process. As we discussed in the first module, in order to understand the student need, we can first utilize screeners. Educators need sensitive screening tools. The screening task should be a task that is closely aligned with Florida standards and the expectations for learning in the classroom at that point in the instructional program. The screening task is used to make both relative and absolute judgments about potential skill deficits. Relative judgments are specifically how one student's performance compares to another's in the same class or grade. Absolute judgments are used to determine how one student's or all students' performance compares to expectations for performance at that time in the year. Both judgments are necessary to correctly define a problem and determine what type of intervention is needed. Some screening models make only judgments, relative or absolute, which can cause decision errors. Curriculum-based measurements, or CBMs, are commonly used as diagnostics, although they are empirically supported as screeners. CBM probes can be purchased through a vendor or online, as well as free online resources such as Intervention Central. The next step is to hypothesize the high probability common difficulties amongst the students, then to select interventions that match the needs. There are numerous high probability common difficulties in math highlighted here. It is vital to correctly identify the barrier to acceleration by analyzing the data. Supplemental programs and materials can be purchased to assist with intervention at Tier 2, such as Fast Math or Accelerated Math. However, existing resources in the school can often be retooled to better serve the needs of students in need of Tier 2 intervention. For example, the resource teacher or intervention coach could provide small group intervention to students receiving Tier 2 supports with daily progress monitoring. The design of any intervention requires a comprehensive understanding of the learning barrier. For example, if student understanding of key mathematical vocabulary is a barrier, then explicit pre-teaching of vocabulary should be included with the instructional design. This document is located in the resource section of the module. It is a tool to assist in the identification of common mathematics barriers, as well as observable student characteristics, effective approaches, strategies, and supports to address the barriers, as well as examples for delivery of instruction across the continuum of supports. The purpose of math intervention courses is to address the barriers that are causing students to struggle in mathematics. It is imperative to identify and address the skill deficit and determine the depth of the gap. meaning collecting enough data to make purposeful decisions around how foundational the skill deficits actually are. All instruction and intervention support should address the development of conceptual understanding, computational and procedural fluency, and problem-solving skills. We must ensure that Tier 2 courses are purposefully integrated back to and within the core content on a regular basis, as well as within the Tier 2 bridging to Tier 1 fluency of application of the skills. An example of this may be a teacher is using a computer program to supplement instruction and build math fluency. This is acceptable as long as the teacher is using the data to drive small group differentiated instruction during core instruction to bridge back. This is an example of a Tier 2 situation. Provide opportunities to make, show, write number concepts utilizing the CRA approach. Enhance core curriculum through problem solving, providing students real-world problems that are relevant to them. Regular, consistent intervention should be in place, in addition to and aligned with core instruction. For example, in addition to core instruction, the heterogeneous groups of students that are all receiving Tier 2 supports for multiplication are also receiving 2 to 3 days per week of supplemental support with aligned materials for 15 to 20 minutes per day. Progress monitoring is occurring bi-weekly through AIM checks in an effort to ensure generalization to core concepts. Let's discuss where to find high-quality intervention programs. There are places to see intervention programs that have been reviewed and the evidence of the studies. The National Center on Response to Intervention is one place. The snapshot that you see here is looking at intervention programs for algebraic thinking. You can see, based on the legend, the evidence ratings. If you were to click on the titles to the left, you would link to the actual report to get a better idea of the studies and how the programs rated. Additional tools are available on the website. The goal of the What Works Clearinghouse is to be a resource for informed education decision-making. To reach this goal, the What Works Clearinghouse identifies studies that provide credible and reliable evidence of the effectiveness of a given practice, program, or policy, referred to as interventions, and disseminate summary information and reports on the website. The Best Evidence Encyclopedia is a free website created by the Johns Hopkins University School of Education Center for Data-Driven Reform in Education. The Best Evidence Encyclopedia provides summaries of scientific reviews produced by many authors and organizations, as well as links to the full text of each review. Some of the primary go-tos for math resources are seen here. The National Council of Teachers of Mathematics and the National Council of Supervisors of Mathematics are foundational resources for all things math. The Center on Instruction provides resources for instruction and intervention across multiple subject areas. The two books identified here have excellent information regarding the provision of RTI in math. Again, these are just examples, and there are many more excellent resources available. As we are attempting to match materials to student need, it is important for us to consider some guiding questions. Do the materials provide explicit and systematic instruction? Are there opportunities to verbalize thought processes? Do the materials use consistent models and visual representations? Do the materials follow the CRA progression? These guiding questions align to the Florida Standards for Mathematics and therefore core expectations of all students. As we have discussed, aligning tiers of instruction is vital. Tier 2 supports are provided to allow students to meet Tier 1 expectations. An infrastructure is necessary to align Tiers 1 and 2. Leadership support must occur, meaning a buy-in from administration. PLCs are effective only when alignment is a priority. There must be time for collaborative planning and communication, which goes back to a leadership support. Materials utilized must align with Tier 1. There must be a generalizable use of specific strategies to match student need. Ensure that the interventionist knows the core expectations to provide aligned strategies. The intervention should be a part of a PLC that unpacks standards. Otherwise, collaborative conversations need to occur between the core teacher and the interventionist. The example shown here is Envision Math by Pearson, a publisher that is on the adoption list for Florida and used by numerous districts in Florida. The textbook used for core instruction also has supplemental materials completely aligned to core. The Envision Math 2.0 program engages learners with interactive learning aids and video tutorials, personalized practice and immediate feedback, and built-in RTI activities in multiple modalities. SuccessMaker is also an aligned Pearson product that many districts have purchased to align to their core curriculum. The next module regards Tier 3 instruction for math. The resources referred to throughout this module are available on the resource list, which includes additional resources broken down by topic.